Alright, now we're going to focus on evaluating trig functions of any angle. You might ask yourself, what does that mean? That's a great question. So really it just means that we're given some information about something, in this case a point, but it could be a line, and we want to find the sine, the cosine, and the tangent of the angle that is formed, and the angle that we're referring to is the angle in standard position. So, what should we do? Very good, draw a picture. Perfect. So, I think about 4, 3, that's in the first quadrant, so I'm going to emphasize the first quadrant. I go 1, 2, 3, 4, 2, 3. That point is going to be here, so my angle in standard position is going to be this angle theta. And keep in mind, now I can just go ahead and I can make a right triangle. So, another big hint about trig in general. One of our main tools is the unit circle. If the unit circle is not going to work on a given problem, the other main thing you can do, or the next go-to thing, should be draw a triangle. So now I can label the sides of this triangle. I know that this side is 4, this side is 3, and if I do the Pythagorean Theorem, 4 squared plus 3 squared equals c squared, I know that this is going to be a 3, 4, 5 triangle. Now I want to evaluate the sine of theta. Sine of theta is opposite over hypotenuse, so that's 3 over 5. The cosine of theta is adjacent over hypotenuse, so that's 4 over 5. And the tangent of theta is opposite over adjacent, so that's 3 over 4. That's it. It's that simple. Let's try another one. Given the point -5, -12, find the sine, the cosine, the tangent of theta. Alright, so we're going to draw again. Where's -5, -12? Third quadrant. Very good. So in this case, I'm not going to tally out a bunch of marks. I'm just going to put a point here, and I'm going to call this point -5, -12. So I can draw a triangle. This is -12. This is -5. This is going to be a 5, 12, 13 triangle. If I didn't know that, I can do the Pythagorean Theorem again. A couple things to emphasize. Notice that the legs of the triangle can be negative. And again, depending on if you've taken a geometry class or not, you know that distances cannot be negative. Or usually we would say sides of shapes can't be negative because they're representing a distance. But keep in mind here, the negative is representing a direction. So the length of the side of the triangle is not -5 and -12. The length of the side of the triangle would be 5 and 12 and 13. The negative is giving us direction, which gives us information about the angle. The hypotenuse of the triangle will always be positive because the hypotenuse is representing a distance. It is representing the radius of a circle, because although this problem is not giving us any information about a circle, or I should back up, this problem is not asking us about a circle, there is a circle here still centered at the origin. That's a beautiful, perfect circle with a radius of 13 now. So it's not the unit circle, but it is still a circle. Okay, and the reason why it's helpful to understand that is, keep in mind, what do trig functions represent? They represent the ratio of sides of a triangle. And so, as long as the angle doesn't change, the sides can get bigger and bigger and bigger, right? Again, if you've taken a geometry class, it's the idea of similar triangles. But the ratio of the sides doesn't change. So it doesn't matter if this is 5 and 12 and 13, or if this is 1, 5/13 and 12/13. The ratios are always the same. Now, we also have to think about, well, what is our actual angle, right? Well, the actual angle is this angle. However, that angle is not inside of the triangle. And so this is where the idea of the reference angle comes in, right? So we're actually evaluating the reference angle here. However, we're still doing it in terms of theta, because if I just evaluate the reference angle, then it's an acute angle, and so then I would get positive values. So the theta Evaluating the trig functions of the theta is what allows me to get negative answers, because that's what puts me in the third quadrant. It's the reference angle that allows me to draw the triangle. So when I go ahead and I say sine of theta equals negative 12 over 13, that's okay. Even though theta is not technically in the triangle, I still know that that is the opposite over the hypotenuse of the triangle that has alpha. And so the sine of theta is going to be negative 12 over 13. The cosine of theta is negative 5 over 13. And the tangent of theta is going to be 12 over 5. Notice that's positive because we divided two negatives. Questions on that? Alright, moving on. I want you to try this one. Now you're going to find all 6 trig functions given the point negative 7, 24. Pause the video, do that, unpause when you're ready to check. Alright, so hopefully for sine of theta we got 24 over 25. Cosecant of theta then is 25 over 24. Cosine of theta is negative 7 over 25. Secant of theta then is negative 25 over 7. Tangent of theta is negative 24 over 7. And cotangent of theta is negative 7 over 24. One thing I want to point out about this, so notice when we have negatives, right? And this just goes to our understanding of fractions. If I write negative 7 over positive 25, or if I write 7 over negative 25, or if I just put the negative out in front, it doesn't change the value. So when we see something like negative 24 over 7, in this case, I got this answer because I drew the triangle, and the triangle was in the second quadrant, so I actually know that the 7 was the negative and 24 was the positive. But if I just gave you information such as tangent of theta is negative 24 over 7, then I don't know which value is actually negative. And even if it's written like this, now in this case, let me back up, in this case I do know which one had to be negative, not because I put the negative by the 7, but because I know that the hypotenuse can never be negative. But when we're dealing with cotangent and tangent, we don't have a hypotenuse in there, and so I'm just trying to emphasize that we don't know which one of the values is actually negative, unless we have more information, right? It could be in 2 different quadrants. If that's confusing, it'll make a little more sense on the next couple problems. So here, find cosecant of theta given that the cosine of theta is negative 4/5 and theta lies in the third quadrant. So why do I care about this, right? Well, because if cosine of theta is negative 4/5, this information could be in the second quadrant or the third quadrant, because cosine is negative in both of those quadrants. So the problem had to give me more information so I know this is the triangle in the third quadrant. So now I can draw the triangle in the third quadrant, and I'm going to say negative 4/5, so I know that this is negative 4, this had to be positive 5, and so this is going to be negative 3 because it's a 3, 4, 5 triangle. I'm going to say that this is my theta here. Cosecant of theta then is negative 5 over 3. Alright, any questions? No? Okay. Alright, so let's try this one. Given y equals 1/4 x is the terminal side in quadrant 3, find all 6 trig functions of alpha. How do we do this? Great question. Well, what is y equals 1/4 x? That's the equation of a line. What is the y-intercept of that? 0. So this is going through the origin. What is the slope? 1/4. So I know this line, right? I'm going to go up 1 over 4 and down 1 left 4. So the line looks kind of like that, right? But we care about the line in the third quadrant. So I'm going to focus on the third quadrant part, and I want to evaluate or find all 6 trig functions of alpha. So I'm going to call this angle here my alpha, and now I'm going to draw a triangle. And how do I draw the triangle? Well, I'm going to draw it like this, like we have, and if the slope is 1/4, I know there's a point on this line that's -4, -1. So I can start to label my sides of my triangle, and I can call this -1, -4, and I can do my Pythagorean theorem, -4 squared plus -1 squared equals c squared. So that's going to be 17, so this is going to be the square root of 17. Now I want you, since we've already drawn the triangle, go ahead and evaluate all 6 trig functions of alpha. Pause the video, unpause when you're ready to check. Alright, so hopefully you got sine of alpha is -1 over root 17, or if you rationalized, it would be -root 17 over 17. Therefore, the cosecant of alpha is -root 17. Cosine of alpha is -4 over root 17, or -4 root 17 over 17. If you rationalize, secant of alpha is -root 17 over 4. Tangent of alpha is 1/4. Cotangent of alpha is 4. One thing I want to point out is just notice how we switched to alpha here, right? It doesn't matter. It's just like any other variable. I can use theta. We're just trying to see something a little bit different. Don't let that be the part that confuses you. Alright, I want you to try and do this. So you need to draw the picture, like we have, and then evaluate all 6 trig functions of beta. Just a different Greek letter, same process. If you are confused on what to do to start, I would get the equation of the line into slope-intercept form so I can draw the line. Pause the video, draw your picture, evaluate the trig functions, unpause when you're ready to check. Alright, so hopefully you drew a picture kind of like this. So I rearranged the equation y equals -2/3 x, right? So I know that I have a line like this, y-intercept is 0, 0 still, but I care about the 4th quadrant, and I know that at some point this line goes through the point 3, -2, so that from the slope. So that is how I drew my triangle. I used Pythagorean theorem to find the hypotenuse. This side is negative, this side is positive. The hypotenuse is always positive. So now I can evaluate. The sine of beta is -2 over root 13, or -2 root 13 over 13. The cosecant of beta then is -root 13 over 2. Cosine of beta is 3 over root 13, or 3 root 13 over 13. And the secant of beta then is root 13 over 3. The tangent of beta is -2/3, and the cotangent of beta is -3/2. Any questions on that? Again, I want to emphasize, notice how where I'm writing the negative doesn't really matter. So here it doesn't mean that the 3 is negative. That just happens to be how I wrote it this time. It doesn't matter. Because we know we're talking about the 4th quadrant. Alright, one more. So here our answer is just a quadrant. So I want you to think about this. State the quadrant in which theta lies if the secant of theta is greater than 0 and the cotangent of theta is less than 0. So I want you to actually try this. Think about where or what makes the secant of theta greater than 0, and also what does it mean to be greater than 0? That's another way to say that. And where or what makes the cotangent less than 0. Pause the video, try to think about that. Unpause when you're ready to check. Alright, so hopefully you came up with that this theta should lie in quadrant 4. And when we say theta lies in quadrant 4, remember, what we're actually saying is the terminal side of theta is in quadrant 4. So if that was confusing to you, I apologize. But that's what we're referring to when we say theta lies in quadrant 4. It's the terminal side is in quadrant 4. How do I know that? Great question. So here I need to think about, okay, well, if secant of theta is greater than 0, that's really just saying secant of theta has a positive value. If cotangent of theta is less than 0, that's saying cotangent of theta has a negative value. So first I thought to myself, well, where does secant have a positive value? How does secant relate to the values or the coordinates on the unit circle? Well, secant is the reciprocal of the x value. So if the x value is positive, then secant will be positive. So in the 1st quadrant and the 4th quadrant, secant has a value greater than 0. Cotangent of theta, if that's less than 0, that means cotangent is negative. How does cotangent relate to the coordinates? Cotangent is x divided by y. And remember, if I divide two numbers and I get a negative value, that means one of them had to be negative and one of them had to be positive. Therefore, in the 2nd quadrant and the 4th quadrant, those are the two quadrants where cotangent will be less than 0. So now I look at this little grid that I drew, and which one has both? That is the 4th quadrant. That's my answer.